burning question you've all had since you've been little kids and you saw your parents pouring giant bags of salt into a plastic bin and you're thinking, what is going on here? What's all this about? There's so much salt. So we'll talk about what this stuff is a hardness scale inside of a tube, and this is a boiler tube that they use to make steam. And hardness that a water softener takes out will actually form a scale that insulates inside of that tube. And over time, it can actually get so thick that it'll plug up the whole pipe. So the next slide. And before we get into exactly how a water softener works, we'll have to describe a few little things. So hardness is usually calcium and magnesium. And the interesting thing about it is it's inversely soluble. It means that as you increase temperature, its solubility decreases. And that's not the case for almost everything. When you're making sugar and candy, you actually heat it up so you can put more sugar into it. And when you get towards like boiling temperature, it's almost nothing that it can hold. So it'll actually form a crystal deposit as you increase temperature, and that's where that water form deposit comes from. You can also see it on shower heads and things like that. All right, next slide. So another facet we'll have to cover is what's water? What's in water? And a lot of people have different ideas of actually what water is, how pure it is. Do we have good water? Do we have bad water? And you need to distinguish between two different facets of it. You can have things like a leaf, which can be filtered out, and you can have things that are dissolved, like salts. And it's kind of hard to see what that is, so I brought a little prop. So we got a cup of water, and we have some salt, and these salts are crystals. And when you put them in there and stir it up, they'll actually disappear, and they're dissolving. So they become disassociated ions that can't be filtered out. It's not a stick or a twig or a fish that can be filtered. It's actually now part of the water. And there's different types of ions. There's two different types, so it's really easy. All right, next slide. And then when you think of a water softener, it's better to describe it as an ion exchanger. So water softener is a type of ion exchange. Next slide. So, like we said, there's two different types of ions. There's cations, which are positively charged, and calcium and magnesium are cations, and sodium we'll also talk about is another cation. Right. And then anions are negatively charged ions. So really not that hard, right? We're all getting it. No one's falling asleep. All right, next slide. So now we're getting into the meat of it. This is a resin bead, and it's an ion exchange resin bead, and they're about half the size of a BB, maybe even smaller, and it's a little plastic bead, and if you blew it up and look under a microscope, it would look like a ball of yarn, and it's got a long polymer strand that's all bound up into a bead. And that strand, as you pull it out, has different exchange sites that attract these ions. And in a water softener, you use cation resin beads, which attract cations. It's actually negatively charged. So if you pull that strand out, it also looks like some people call it a trot line down in Louisiana. They hang it across the swamp to catch fish, and it's just like a rope with a bunch of hooks on it and meat, and fish just jump up and eat it. So you catch lots of different ions on one strand, and to make it more compact, it's bound up. All right. So with a water softener, you have some type of vessel, and you have thousands of these beads that make a bed inside of a vessel, and you pass water through it. So the water has got ions in it. Calcium carbonate is the biggest constituent of hardness deposits. So you're actually passing water through with calcium carbonate. As it goes through that resin bed, the resin is charged with sodium ions, so that piece of yarn with all the exchange sites is preloaded with sodium ions. And as the calcium comes through, it'll knock off a sodium ion and will grab onto that calcium ion, and it exchanges. So the calcium carbonate is exchanged and becomes sodium carbonate at the outlet. You haven't taken anything away on a mass basis, it's just exchanging it. And then in order to replace the calcium and put sodium back on the beads, you have to regenerate it, and that's where the salt comes in. So you have a brine solution that you push through a softener at a very high concentration, because the sodium is not as attracted to the beads as the calcium. You have to use massive amounts of it to replace it. So you put a whole bunch of salt in there and it throws off all of the calcium, and you've reloaded it with sodium, and then you put it back into the service cycle. And that's all there is to it with a softener. But the brilliance is that this technology can be applied in lots of different methods, like in a demineralizer, or in the nuclear industry, they'll actually capture nuclear isotopes by passing it through a resin bed that's specifically attracted to isotopes. So it's a pretty elegant, simple technology. You have no idea who figured it out, but it's just ingenious. And I'll show you on the next slide the demineralizer real quick. So you have a cation bed, which is a softener, but it's loaded with hydrogen. And you have an anion bed that's loaded with hydroxyl. And when you put water through it, it has salt, sodium chloride. The sodium is exchanged, and you get hydrochloric acid. And then that comes back up to the top of the anion bed, and the hydrogen, or the chloride ion, is exchanged with hydroxyl, and you get HOH, which is just pure water. So all of your cations are exchanged here, all of your anions are exchanged here. You get absolutely pure demineralized water, and it actually makes water. So you have more water at the outlet than what you have at the inlet. So it generates it. It's pretty interesting. And in a nutshell, that's water softening technology and demineralization. We won't have to talk about it ever again, I promise.